Take the time to dig deep underneath this red heat. We could really meet. Layers. It's time to lose these naysayers. We're better off, the air will be richer.
Hi YouTube and welcome to another video. Now today's video is going to be all about my 12-volt electrical system in the camper van and a bit of information about how the systems work, how our systems work, and a little bit about each component. I'm going to try and make this video going to be a complete kind of look into electrical systems in the van, kind of sticking at the 12-volt systems. Obviously we do have two 40-volt systems in this van by means of an inverter and site hookup, but I'm not going to be including them in this video. It's going to make it too long, and I will be doing one in the future, probably just a quick one about our 240-volt system. But this one's going to be all about our system, how it's fed, how it's charged, and what it goes into, and just a little bit of information about battery setup and kind of what you might want to do for your setup, with a few tips, tricks, and kind of the way I went. Hope you find it useful. Hope it helps with your conversion if you're thinking of doing one. I'll get set up now at the battery. Right, the first component I'm going to be looking at now is the battery. Now the battery is your main component. It is the hub of your 12-volt electrical system, and you want to be thinking of it as the energy store that is going to allow you to power your devices, charge your phones, devices in the back of the van, power your lights, and also accept charge and input from other devices such as a solar panel or a 12-volt charger, or stuff when you're on a site hookup. Now there's several types of batteries. This one here is actually the starter battery. I've removed the cover so you can have a quick look at it. This would not really be suitable as a leisure battery, but it does share many of the same components. You both have a neutral and a live on this one, as you do any battery. And also we can have a look at it and kind of look at those connections to work out the ones that are on the leisure battery. I'm not going to be able to show you the leisure battery live today, simply because it is stuck under the seat and I'm not unbolting the seat just to show you that. I can show you some old footage and you'll kind of get where I'm coming from. But basically we're going to be looking at batteries at the moment. Now the first thing to think of when you're looking at a battery is the capacity. Now capacity is measured in amp hours, often abbreviated to AH. The larger the number, the more energy your battery is going to store. This is a 70 amp hour battery. It doesn't have a massive store, but we don't really need that with batteries that start the engine. We need something else, which is a CCA, which stands for cold cranking amps, and that is the amount of power you can push out at a time to do heavy jobs like start engines. So when you see any leisure battery of CCA measurements, you don't really want to be worrying about that figure. The figure you are worrying about is the one that's AH. Like I said, the starter battery in this is 70. That is quite a small battery. You wouldn't really want something that small for your leisure battery. The leisure battery we have in this van is 130 AH. That's 130 amps an hour, or amp hours. So basically you want to be looking at the biggest capacity battery that you can afford, but also the biggest capacity battery that will fit in your vehicle, simply because the bigger the capacity, the bigger the battery, and you'll get to a point where the battery becomes so big that there's a chance it won't actually fit in the space in the vehicle, or the space you have where you want to store the battery. So that's one thing to consider, that battery dimensions, physical dimensions, do get a lot bigger when you start increasing battery size. So basically, as a rule of thumb, the biggest capacity is going to last you longer. It's going to power your devices for longer without going flat. It's going to give you a bigger energy store. The downside is cost and physical size and weight of the battery. That's the first thing. Once you've decided what capacity you want, the next thing is the battery type you want. Now, depending on the battery type of technology you buy, it's going to affect how long that capacity is going to last and how much of that capacity you can use. Now, this is a wet cell battery. They do often vent hydrogen gas. They can be explosive. So you want to have these in vented areas. You don't really want to be using them as a levered battery. They're not really suitable, especially if you're going to be cooking in the van. So I wouldn't recommend using a wet cell or a gel cell battery. That's two types of technology. And also with a wet cell and a gel cell battery, you can only use 30% of the capacity. So if you have a 100 amp hour battery and it is this technology, a wet cell or a gel cell, you can only use 30% of that. So you can only use 30 amps. You have to stop using it when it gets to around about 70 amps left in reserve. Otherwise you will start damaging and reducing the life of the battery. So the next technology on from that, which is our Ledger battery, is something called an AGM, which stands for Activated Glass Mat, and it's a technology that allows you to get a bit more capacity out of it. With an AGM battery, you can get 50%, or you can use 50% of the capacity, which means out of a 100 amp AGM battery, you will be able to get 50 amps of use. And like I said, a wet cell battery, you'll only be able to get 30 amps of use. Now, battery weight and size between an AGM and a normal wet cell battery are the same. The cost is slightly more, but as you can see, you'll be getting 20 amps more out of an AGM battery. You'll be getting 50 amps total use opposed to 30 amps total use. That's if the batteries are both 100 amps. We have a 130 amp hour AGM battery, so we can get 65 amps use before that battery needs to be charged. Now, there is another technology which you can also look at, which is lithium ion. It's a newer technology. They're a bit more difficult to fit and install. They need more complicated charging methods, and they do need to be done properly. They can be quite unsafe if they're not properly installed. But with those, you will get 80% of the capacity available to you. So if you had a 100 amp hour lithium battery, you could use 80% of that, which means you could get 80 amps of use. They do last really long. They are also quite reliable batteries, and they tend to outlast the other Ledger batteries you can buy, probably by about 2 to 3 years. They are quite good batteries when it comes to longevity. So definitely recommend looking into lithium ion. I would recommend, if you're on a lower budget and you want to do it traditional way, an AGM battery, biggest capacity you can get. But if you want to spend a bit more money and probably get the best system you can, probably look at lithium ion. They do have other benefits as well. Like I said, they last a few years longer. They have more capacity, and also they're lighter and smaller, but they do require more complicated charging systems to charge them. So overall, you have to work out the costs and what's best for you. I'm going to take you to the back of the van now, just because it's starting to rain quite a bit. There's not much more I can show you from here. I'll get in the van and I'll chat through some of our other systems, what we have running off our battery, and various other things inside the van. I'm in the van now. I'm out of the rain, which is ideal because it's starting to pick up. So once you've got your battery selected, you know your capacity that you want, and also you know what type of battery you want. The next thing is to think about a place to put it. Now, ours is under the seat. It does just fit. We have a 130 amp one, like I said. It's a very big battery, and it does just fit next to our diesel night heater in there. You can put them anywhere you want them, really. Anywhere they'll fit, anywhere that they're going to be safe, and nothing is going to kind of contact them or kind of foul the top where the connections are. Like I said earlier, some batteries aren't that well suited for inside the van. So if you are going to have a wet cell or a gel cell battery that is vented, that does vent to the outside atmosphere, make sure it is stored in a sealed container or a sealed battery compartment. If not, like us, you simply have a battery under the seat. Make sure it is a fully sealed or internally vented battery. Lithium ions and AGM batteries generally always are, but do check. Wet or gel cell batteries often aren't fully sealed. You can get maintenance-free ones which are semi-sealed, but make sure that they generally don't vent to the atmosphere when they're being charged or when they're in use, just to make it a lot safer. We cook on this hob and our battery is under the seat, so obviously I've made it as safe as I can, and we do have a fully sealed AGM battery under there. So once you've decided where the battery's going, make sure it's all secure, make sure you've stopped it from going anywhere and it's kind of secure in there. The next thing is simply wiring it up. So you want to have all your components in the van fused. So we have 1/2 foot cable from here into this cupboard, and then in the back of this cupboard we have our fuse board. We have every single component in this van is fused at that point, and you want to be fusing your components as close to the battery as you can. That means that the wire, you want to have as most of the wire after the fuse and very little amount of the wire kind of between the fuse and the battery, if that makes sense, to make it a lot safer. Once you've done that, wiring up individual components, there is 2 ways of doing it. You can either take a live from that fuse board to the components live, or where the live goes in, and then the neutral of that component, you can even run it back to the neutral of the battery. You'll probably soon find by doing that you end up with too many wires going onto the neutral of the battery. So what you can run is a wire or a thick wire from the neutral by the fuse board, and have a load of separate connections in there that just for the neutrals. Or if you want, you can just connect that neutral to the body or the earth of the van, as long as you have earthed your leisure battery onto the body of the van as well. Most vehicles are what they call neutral earthed chassis, or kind of neutral chassis, where the body of the van is also connected to the earth of the battery. So the best situation, or what I'd recommend, is to run your live off the fuse board and then your neutral back towards the battery, and have it on a separate connection or a buzz bar that goes onto the battery's neutral. If for some reason you can't do that, you're in a tricky situation, you can't get all the wires down there, or you're in a place where you just can't do that, you can just put the neutral onto the chassis on the van, kind of an earth on the van somewhere, a bit of the bodywork, and it should complete the circuit and work for you. Now, a quick word about fuses. You want to be overrating your fuses. So our fridge, for instance, or our cool box, for instance, runs at 4 amps. You want to be having more like a 7 or 8 amp or even a 10 amp fuse on that, because when you first switch on components, they always draw a lot more power in those first few seconds you switch them on, that it actually causes them to run. So if you have a fuse that is exactly rated to the device, chances are you will blow that fuse every time you switch the device on. So once you've done that, you've got all your connections done, you've got all your stuff fused, and you've got all your components done. You want to be looking at wire sizes, which I'll go through now, for the individual components. Obviously, as well as matching the fuse, you want to be matching the wire size to the rating of your device. So if I have a 4 amp cool box here, I want to be looking online and making sure that the cable I buy is rated for 4 amps or 6 amps or something like that before I use it. So obviously match your cable size to the demand, what you need. If you were to use a smaller cable size, you run a risk of the cable getting too hot and overheating. And also just run your cables really neat, out of the way of anything that's going to trap them, anything that's going to damage the installation, and anything that's hot or going to melt through them. 12 volt systems are generally really safe because they're only 12 volts. You have very little chance of being electrocuted by them, but batteries do have a horrendous amount of power in them, and they can, if the wires are short circuited or connected wrong or joined together wrong or damaged in any way, they can put out a hell of a lot of power to the point that it could potentially start a fire or potentially even make the battery explode. So just be careful. They are generally safe systems, but make sure you do your wiring very neat, have everything fused, and don't just kind of chuck stuff in cupboards hoping it'll be okay. Now once that's done, you're going to have to start looking at some charging systems to keep your battery charged. Now the first system I would recommend looking at, is one we use, is a split charge relay system. Now I'm not going to go into the finer details and the points of fitting these, because there's lots of good videos on YouTube that tell you how to do it, and our system is a bit of a unique one because I've used some of the connections that came with the van when I bought it, because there was originally an amplifier for a subwoofer back here, and I've used the cables and the trigger feed, which is something that remotely switches it on and off, from that system to go into our battery. So I'm not going to go into that because it's not really a system that most people will be using or doing, but to just basically say there is two types of split charge system. There is a volt sensing system, and there is a normal cheaper system, which is more like the system I've used. Generally speaking, a volt sensing system is going to be a bit more expensive, but it's going to be a lot simpler to fit. It's going to involve fewer connections, and it'd be a lot easier to set up. Now, you want to be thinking of a split charge system as giving you one type of charge. It's not going to be great for your battery, but it's going to allow you to give it a quick bulk charge, a kind of big oomph of power when you're driving from location to location, or if you need a bit of power at short notice, you can just run the engine up and it will give you that. But split charge systems only really will charge your battery to about 80% of its capacity. And if that's the only system you were to use on your battery, after a year or so of that, you would potentially start reducing the capacity of your battery and damaging it to a point where it's not going to run its optimal. So you want to be thinking of a split charge system as a two-prong attack. You want to be thinking of it as a bulk free charge almost, that you're getting when you're driving. It's very convenient, but it's not something that is going to maintain your battery. For that, you want to be looking at a few other solutions on top. One solution is a normal battery charger which plugs in your mains at home. You can use them on site hookup, and obviously when you're parked up at home. Now the problem with that, they're not very convenient. You have to be by mains power. There is another system which is a 12 volt to 12 volt charger, which is something which will run a bit like a split charge relay. It will run off your engine battery when the engine's running and charge your back one. The problem with those is you need to have the engine running for them to work, which means you're going to have to use fuel, and it's going to not probably the most efficient system. You do, as a matter of fact, need to use those 12 volt to 12 volt charger systems with lithium ion or LiPo batteries. A normal conventional 12 volt split charge system won't work with those batteries. So if you're going to go down that route, it will be something you need to look into, a system that will work with your LiPo batteries. The other system you can use, which is what we use, is a solar panel on the roof. We use a 120 watt solar panel. That gives us, on a really good day, anywhere from 2.5 amps to 3.5 amps of power per hour. The battery is 130 amps, so as you can see, you're going to have a few days of good sunlight to recharge the battery. But the good thing about those systems is when they do charge the battery, they charge it really efficiently and they really give it a good condition, give it a proper charge. I'm going to take you out the back now, quickly show off our solar panel system. It's kind of stopped raining, although it is very misty outside. And I'll catch up with you around the back of the van in a minute. Right, you have to forgive the mess in the back. I normally have it set up like this now because I try and go away in this van probably once a week or sometimes once a fortnight, just for a night with a bit of photography. This is our solar panel charge controller. Now this is an Mppt one. There are two varieties. There is a PWM and an Mppt. Now they're really good systems because they automatically will not just charge your battery to 100%, they will do it free from the sun, and also they will condition your battery. So if you have a split charge relay, like I said before, to do your bulk charge, and then you have this on top, which is trickling into it on those sunny days. It will really help you get the most out of your battery, and it lasts as long as it possibly can. Now, like I said just a minute ago, I was in an Mppt, which stands for multi-point power tracking. The other system is a PWM. They're two slightly different systems. They both do the same job in different ways. Now, depending on the size of the solar panel system you have, one will be more appropriate than the other. So anything around 120 watts or maybe even 150 watts or below, you probably want to be looking at a PWM system, which are cheaper, generally a bit more reliable. And they're also probably more efficient at that wattage as well, that power. Anything from 150 watts onwards, you probably want to be looking at an Mppt. Now, like I said, we do have a 120 watt system, so a PWM probably would have suited our system. But I wanted the Mppt, and I'll go through the reasons for that now. So an Mppt system works by reserving more power at the cost of using a bit more power to reserve it, if that makes sense. I'll go through it a bit better. So when you get sunlight hitting your solar panel, it actually comes in at about 19 volts. Now, the battery only runs at, say, anywhere from 12 to 14. So this system here has to convert that 19 volts down to, say, 14 volts, something like that. So what does it do with that extra, say, 5 volts that gets lost? Now, a PWM system will literally just throw that 5 volts in the bin. It just gets lost. You lose that energy, it doesn't go anywhere. You get the 14 volts that's needed, but that extra energy in the 5 volts is just binned. An Mppt system will convert that extra 5 volts into current, which means you get 14 volts, but you get more actual power going and you get more charge going into your battery. Now, the problem is, the downside is it takes about half an amp for this box to do that conversion. So although you get more power from the system, it's using more power to get that extra power. So in a country like the UK, when it doesn't get that hot or we don't have that strong sun, and a lot of our summers are a bit overcast, the system to probably use is a PWM. And also, if you're below 150 watt, the system to probably use is a PWM. Now, the reason I went for an Mppt is because when we use the van, we often go to Europe in it for a month at a time. You get hotter days over there, you get more power on the solar panel. Some days this thing goes up to 3.5 amps. So in those situations, the situations where I'm away for a month and I'm not always guaranteed to get any proper 240 volt hookup to charge it, the systems when I'm kind of wild camping, staying in random places, not on campsites, I need as much energy as I can get in the battery. And this system in hot countries in the summer will give me a bit more charge. It will work better. The downside to it is on cloudy days in the UK, this system won't give me any charge at all to that battery, whereas a PWM will trickle in slightly and help kind of maintain that battery. So they're two systems. The Mppt ones are generally a bit more expensive, can be a bit more unreliable. Totally depends what system you want to use. But basically our system for the 12 volt battery on our van is, like I said before, with the setup, the battery we use, and this is how we keep it topped up. So I'm just going to summarize basically now that the system that we have is an AGM 130 amp battery that fits underneath our driver's seat. We keep it topped up with 120 watt solar panel on the roof, which is fed from this charge controller here, which is an Mppt. And that's pretty much our system. It's kept topped up with this and a split charge relay. To summarize general systems, you want to be looking at the battery technology type you want. I would recommend an AGM or a lithium ion. The biggest capacity you can get for your system is going to give you more storage, more energy you can use, make your battery last longer. obviously at the expense of being able to fit it in certain places. And generally speaking, the ways you want to keep it charged are two ways. You want to probably be doing a split charge relay for when you're driving. They are cheap systems to put in. You can put a split charge relay in anywhere from 20 to 60 pounds. And then on top of that, you want to be looking at another system. I would recommend a solar panel because it's cheap, it's free, and as long as the van is parked outside, it's something that's just going to be trickling over throughout the day without you having to do anything to that van. It's just going to look after itself, basically. Wiring wise, make sure you fuse every single wire you can, every single device be fused. Make sure every bit of bare metal is insulated. If you do need to join wires, either solder them and use heat shrink tubing or bullet connectors, proper electrical connectors, or if you do need to join them in a connection block, make sure it's insulated in a case. I apologise in advance, this is a very long video. It's quite an involved and in-depth video, this one, but I wanted to go through it, and that's simply because one of the main questions I get asked on the channel, and I also see it on a lot of Facebook and groups, is about 12 volt systems, how they're put in, what systems people have. So I just hope this has answered some people's questions about our setup and about a setup that you can use. You want to be looking at budgets somewhere probably around about £500 for a battery system with all the wiring, with the fuse box, with the solar panel and the charge controller. Lithium ion will probably cost you more, but you'll be able to get more capacity for less weight, and it will generally last a bit longer. Now, quick thing about the life cycle of these leisure batteries. Every time you go below the capacity of the battery, like I was saying to you earlier, this is an AGM. It has a capacity of 50%, so I can use 50% of the battery. And like I said, with our 130 amp battery, we can take that down to 65 amp before it becomes a problem. Every time you go past that, past the minimum charge state that it's meant to be maintained at, you do what they call deep cycle your battery. You basically degrade its life. Now, batteries are designed, or leisure batteries are designed with a life cycle of deep cycles, the amount of deep cycles you can do before they start failing, or before they get significantly reduce the capacity. So it's another thing to look at. If you do think you are going to be getting to a situation where you are probably going to be depleting your battery a lot, look at batteries that have high life cycle or high deep cycle kind of capacities. Ours is 300 cycles. That is average for an AGM. A wet cell battery like the one that starts the engine, you normally get about 200 in leisure battery form. Lithium ion batteries or lipo batteries, you can get about 800 to 900 cycles, so that's why they generally last a lot longer. I would expect a system like we have to be fully charged and maintained with the panel and the split charge to last somewhere around about 5 years to 6 years, and lithium ion system could last potentially up to about 8 years, so they will last a bit longer, those lithium ion batteries, and you can abuse them a bit more. Thanks for watching this one. I hope you found it interesting. You probably noticed the van has been two-tone now. I'm looking forward to getting a few more things done on the van, a few more things updated. I'm really looking forward to getting another update on this van because I've not done a proper update video on it now for 2 years. Thanks for watching. If you found it useful, please like, and if you want to subscribe to the channel to see more van related stuff coming up, or even photography stuff, please subscribe. I'll be linking up, you've probably already seen in this video, lots of spurs off to other videos about bits I've done. Please check them out, you might find them quite useful, and I'll catch up with you on the future on the next vlog.